So in this problem, you have to find out the interaction force between the dipole and a long line charge or infinite line charge. See, there are three cases here. We have to find the force acting on the dipole if the vector P, dipole moment vector, is parallel to the thread. So let's do that case first. This is the thread having charge density plus sigma, and you know that this field lines are radially outwards and this dipole is placed parallel. So this is plus q and minus q separated by a distance L. So that dipole moment, the magnitude is q multiplied by L. But you see here the force has to be 0. The force has to be 0, though there is a torque, because it is equidistant, right? So it is at a distance r. So here the field is suppose E. So this force is q into E at this place, and here also field is E as the charge is negative. So the force is QE. So for the first case, the value of the force will be 0, though there is a torque. Okay, let's try out the next case where the dipole is placed along the radius. That means this is the dipole, minus q and plus q. Okay. So this we'll solve it in another page. So this is the line charge, the infinite line charge, infinitely long, and here you have a dipole, this charge minus q plus q, and this is L. We have to find the interaction force between this line charge and the dipole. So here what we can do is that this L is so small, L I can consider it dx, and this I can x, and at x the field is E, and if this is dx, so at x plus dx this length is taken as dx, at x plus dx the field can be taken as E plus dE. So E is a function of x, right? E is a function of x. So the force on this charge is q into E plus dE, and the force on this negative charge is obviously here q into E. So we can calculate the net force on the dipole as net force on the dipole is q into E plus dE minus q into E. So that is q into dE. So we can write like this, q into dE by dx multiplied by dx. Now this q into dx, this q into dx multiplied by d by dx. Now this q into dx is equal to the dipole moment, and dE by dx, ddx of, so E as a function of x is lambda by 2 pi epsilon naught x, that we know of. So there, in this case the force is P into there is a minus sign, into minus lambda by 2 pi epsilon naught x square. Now as this x is given as r, actually we have to take this distance as r, so f is equal to minus p lambda by 2 pi epsilon naught r square. Minus sign, why this minus sign? Because we have assumed the coordinate r this way or x this way, so it shows that the force is attractive. So this is the direction of the force, that is why it came out to be minus. Okay, now there was so this is the answer to the second case, second question. Now in the third part, the orientation of the dipole is at right angle to the thread and also the radius vector. So here it is, right? So this is the radius vector r. This is perpendicular both to this and this. So obviously the dipole is placed along this. So it is perpendicular to the plane of the paper. So we'll do one thing. we will view the thread as a point. That means we are viewing it from the top view. So there's a top view, and there at a distance r, you have the dipole like this. Here is the dipole, plus q and minus q. Now, so here you have to find the force within the dipole and the line charge, and obviously the field lines are radial. So at this point, this is a field, this point also this is a field, but the force here the field is q into E, and here the force is q into E because of negative charge. Now if you resolve these forces, then this component and this component will obviously cancel. So this component and this component, these two will add up. So this is theta, this is also theta. So the net, and so this is theta. So this is actually QE times sine theta. QE times sine theta. This is also QE times sine of theta. Okay. So let's take this as capital R. So E is equal to lambda by 2 pi epsilon naught capital R. So the net force happens to be twice QE times sine theta. So that is twice Q into E is multiplied by sine theta. Now that's L. See, if the dipole length is L, so this is half of L. Okay, let's draw the diagram here. So this is L by 2 and this is R. So it's L by 2 divided by R. So that's so this 2 will cancel out. So Q lambda L divided by 2 pi epsilon naught capital R square. So actually capital R and small r, as this is a very small dipole, so capital R and small r are nearly equal. So you can write the force as so this Q into L will make P. So P lambda by 2 pi epsilon naught R square. And the force, the direction of the force is along this direction, upward.